All right, hello, ladies and gentlemen. This is section 8.1, Introduction to Confidence Intervals. Okay, you'll need a graphing calculator. You'll also need a paper, pencil, and maybe the note sheets for this lesson. All right, so once you have those, we'll click on the arrow and we'll be ready to go. All right, now I'm giving this presentation in January, so it's practical to my time right now. This paragraph reads this. It says, the holiday represents a time when many spend a lot of money buying gifts for family and friends. Listed below are credit card statements during the month of January for 30 random US families who use their cards exclusively for holiday shopping. It says assume the standard population standard deviation is sigma is equal to 120.4, which means $120.40. All right, now, usually when we associate a standard deviation within a problem, it's related to a mean, okay? And ideally, it would be nice to know what our population mean is, okay? However, because there are so many data values that could represent this mean, okay? And when I say data values, that represents every single credit card statement for the month of January for people who use their credit cards for purchases for gifts and things during the month of December. Because that group of people would be so large, okay, it's what we'd say is too difficult to find, okay? You can't ask everybody in the United States, hey, can I see your credit card statement for your either bill or bills, because some people have more than one credit card, for the month of January. You just can't obtain all that, and then once you do, you could find an average, okay? So this is, again, is usually too hard to find. Okay, and if it's too hard to find, okay, the most we can do is kind of estimate what this may be, okay, and that's what I'm going to find down here, a point estimate. Okay, and since I'm talking about means, okay, and mu is kind of the all-purpose type of calculation I'm really looking for, which is again too hard to find. The best thing I could do is find a sample, okay, and our sample mean is represented with an x bar. Okay, and I coincidentally have a sample of 30 credit card statements, okay, that are from across the United States, and those are the values, okay, the dollar values for what was spent during the month of December, and then stated for their January bill, okay. So here's what I need you to do, okay, and this is probably the hardest part of today's lesson, okay, is take all these data values, all 30, okay, and store them in L1, okay, of your graphing calculator. Remember, the way you get there is just by hitting stat, okay, and then just hit enter, okay, and then you can list all of those in L1. And then to find the X bar, remember it is the 1-bar stats command, okay, so the way we do that is we hit statistics again, stat, and then we scroll over to calc, and it's the first item. It's one variable statistics. Okay, and the first item you'll see is your X bar. If you take a moment, plug all those in your L1, okay, and actually follow through with this command, okay, I will just tell you that you get 1004.5. Okay, that is the mean of these 30 credit card statements. Okay. All right, and so that's what your point estimate is. The idea is that this, kind of in hope, kind of in theory, is somewhat close to what this population mean is, but nevertheless, there's no guarantee, okay? Again, this guy here is too hard to find, so we have to depend on moments like this where we have random samples to create small calculations and hope that comparatively, this is a good estimate for what our true population parameter would be for a mean. Okay. All right, so I'm going to take that information and use it on my next slide. Okay, and it says draw a normal distribution and label the mean and 3 standard deviations in each direction. Okay, so I'm just going to draw a couple of them. I'm going to draw the first one. I'll probably just draw it right here. Okay, and right down the middle, we're going to put the mean, and our mean we said was 1004.5. All right, and it says to draw and include 3 standard deviations in each direction. Okay, now I'm going to flip back to the other screen in just a second. Remember this: the standard deviation of a sampling distribution is the standard deviation of your population divided by the square root of n. Okay, and so I do have 120.4 as my population standard deviation. Okay, my n, which I can look at on the previous slide. Okay, previous slide. These are all samples of size 1. Okay, these are just credit card statements. Okay, and so these are all n equals 1. Okay, very kind of fundamental. They aren't. This is not a sampling distribution of samples of size, 2 or 3, where we're averaging them together and creating little means. Okay, if that makes sense. These are just samples of size n equals 1, and in the end, there's 30. Okay, and so in this case, okay, I don't have a big sample size. I just have n equals 1, and so it just turns out to be 120.4. Okay, and so what I'm going to do is I'm going to go 3 standard deviations in each direction. Okay, when we do that, let's see, I will get 1,124.9. If I do the next one, it's 1,245.3, which is really 30 cents. And the last one is 1,365.7, okay, or 70 cents. All right, and if I go the other direction, 3 standard deviations. All right, going the lower end, it looks like it's 884.1. Okay, another one, next one is 763.7. Okay. And the last one is 643.3. All right, so these represent 1, 2, and 3 standard deviations away for the credit card bills for this particular sample. Okay. Now, I want you to go back and remember something from an earlier chapter, probably chapter 2. I'm drawing the same curve here, and some things I want you to remember based off the mean. Okay, so remember that this is 1 standard deviation away. Okay, that would make sense. We've drawn the line in the more positive direction, representing 1 positive standard deviation. This one is 1 negative standard deviation, so plus or minus 1 standard deviation away. Remember that represents 68% of all the data within. Okay, and if you go 2 standard deviations away, okay, that represents 95% of all data. Okay, within, and again, that's plus or minus 2 standard deviations in each direction. And 3 standard deviations, which I think I failed to draw those in, but I'll put those in right now. Plus or minus 3 standard deviations, that represents 99.7, and sometimes we just call it 99%, just to make things a little bit easier for us right now. Okay, but yeah, 3 standard deviations in either direction, plus or minus 3, again, represents about 99.7% of the data, but for now, we're just going to call that 99. Okay, and so when you think about these 3 sets of boundaries representing distances for standard deviations, you can put them in a practical resource with the items that you created for your credit card bills with a mean and your respective standard deviations 1, 2, and 3 in each direction. Okay. Now, how are we going to use those? I'm going to have to refer back to this. Okay. Off and on. So I may bounce back to the screen. Well, here's what they're going to do. They're going to say, hey, describe a 68% confidence interval. Okay, and again, I'm using basically this picture to help answer that question. All right, so let me get a darker item to write with. All right, now 68% confidence interval means that I'm going to take my X bar, I'll write it real small off to the left here, and I'm going to add just one standard deviation in each direction, one in the positive direction, one in the negative direction. And what you find is I end up with these boundaries, okay, which is $884.10 and $1,124.09 or 90 cents, okay? And here's how my, my description is going to go as it's written, okay, because this is one standard deviation away. And they're kind of all written the same way. So what you see written this first time is a kind of a structure that you'll see represented many times through not only out this lesson in 8.1, but for this entire chapter, for chapter 8. Okay. But here's how I'm going to write it. I'm going to say, we are 68% confidence. Okay. The interval, okay, from, okay, and this is where the lower boundary and the higher boundary come in, okay, $884.10, okay, to $1,124.90, okay, captures, okay, the true population mean, okay, for January, okay, credit card statements. Okay, so again, let me read this out. I'm going to get another color to highlight some items here. I'll do this in, I guess, red, just because it'll show up. I'm going to read this again, and this is kind of a formatted sentence that we will always describe confidence intervals for. Okay, so it says we are 68% confident. We can see where we got that. That's what the question asks. The interval from 884 to 884.10, which is $884.10, to $1,124.90. Okay, that's from here to here. Okay, if I darken these boundaries here on my normal curve, okay, captures the true population mean for January credit card statements. Okay, and what we're basically saying is this. I'm going to go back up to the top. I have no idea what the mean credit card statement for every single person is, population-wise, for the month of January. I do not know, but based off my one sample, okay, where I had 30 items to put together, I'm 68% sure that the true mean, okay, for the population is somewhere between $884.10 and $1,124.90. Okay, so that's where I'm at. Okay, there's some certainty that the true population average is somewhere between those two. Okay, now if I want to be a little bit more certain, okay, and I want to go with a 95% confidence interval, what that means is, well, 95% means I'm going 2 standard deviations out. Okay, so I'm going to rewrite basically the same sentence. Okay, the only difference is I'm going to use these bigger boundaries, okay, for 2 standard deviations, and a different representation for my confidence interval. Okay, so as you look over here to the far left under part B, I have X bar plus or minus 2 standard deviations. Okay, and here's what I'm going to write. I'm going to say we are 95% confident. Okay, the interval from, okay, sorry, that's tough to read. And again, I'm going to go 2 standard deviations out, so that's 763.7. So I'll put my dollar sign there, 763.70 to, okay, 2 standard deviations to the right, $1,245.20 captures, okay, and it's pretty much the same sentence. The true population, okay, mean for January credit card statements. Okay, so again, the idea is I don't know what my population average is. I don't know what the average bill is, okay, for each credit card statement, okay. Let me restate that. The total statement debts, if that makes sense, for everybody's January month. But I am 95% sure, based off my sample, that the population average is somewhere between $763.70 and $1,245.20. All right, so that's all I know. I don't know what the population mean is, but there's a 95% certainty, 5% confidence that it is in between those numbers. And again, we want to make sure we write our sentences in this structure, okay, so it looks kind of coherent in terms of how we represent our answer. Okay, notice there's context at the end, talks about the mean credit card statement at the end. And again, you're including the 2 boundaries and again, the title of the confidence level you're using. Okay. All right, last thing is a 99%. It's just like all the others. The only difference is that your X bar is going to have 3 standard deviations. Okay, and we know what 3 standard deviations is. It gives you a boundary. Lower one is 643.3, okay, and a high boundary of 11365.7. So we'll write that in context with money, and it'll go like this. We are 99% confident, okay, the interval okay, from $642.30 to the interval $1,365.70, okay, captures the true, and the rest is just the same as before, population, okay, mean for January credit card statements. Oh, darn it. Okay, so there we go. All right, now some will say, gosh, this feels kind of redundant. Do I always have to keep writing these sentences over and over? You do, okay? In terms of how you script it, that's how you're graded, all right? All parts of this representation is super, okay, important, okay? And I know they're the same for each one other than, you know, we changed the percentages and changed the calculations for each. I know that's not the hard part, but the sentence structure is super important. Okay, so we want to make sure that we include those for each of our answers. All right, that's kind of the hardest part, but if you can nail that, you understand the chapter. Now, think about this one more time, as we've talked about previous ones. 99% confident, what does that mean? Well, here's what it means. Here's my 99%. I don't know. Again, on the very top here, I'm circling this a ton of times. We're out of frustration because I can't find the population average for all January credit card statements. It's not possible to do. But based off my one sample, okay, what I can say is that I am 99% sure, based off my sample, that the true average, okay, the true population average has to be somewhere between $643.30 and $1,365.70. And you're like, dang, that's a pretty big gap, you know? It's like, that's a, you know, that doesn't really give a lot of specifics there. That's true, okay? But that's why we're allowed to use a high percentage number like 99%, okay? All right, last thing is more vocabulary, and this is really easy despite words that look kind of intimidating, okay? As we look at this last part, it says, for a 95% confidence interval, what is the critical value, okay? And what is the error? Okay, so let me go back to 95%. This is B, and it's written in red. So if you can look back at my PowerPoint here, I'm going to circle B real quick. It's right here. And underneath it is where I wrote my kind of a little formula. Okay, it says X bar. I'm going to write over here to the right, kind of close to my picture. X bar plus or minus 2 standard deviations. Okay, that's kind of like our algorithm for finding the boundaries for a 95% confidence interval. Okay, now your critical value is easy. Okay, your critical value is basically your number of standard deviations that you're either adding or subtracting from, in this case, your mean. Okay, or you're going to be more general, you can say from your point estimates. Okay, so in this case, we're just adding 2. Okay, so underneath my 2, I'm just going to say this is my critical value. Critical. Let me erase that because that's going to bother me. Okay, so this is my critical value. Okay, so that's an easy answer. This is 2. I'm just going to circle that right next to critical value. And the error is everything behind your point estimate. So basically, it's 2 times sigma. Okay, 2 times your standard deviation. Okay, now what does that mean? Well, we said earlier that my sigma was 120.4. And if you add those together, multiply those together, you will get 240.8. Okay, and so that right there, that's the representation of your error. Okay. All right, so easy stuff. Error is just multiplying. Critical value is just the number that's in front of your standard deviation. It's how many standard deviations you're moving in each direction. Okay. Some people said, hey, you know what? If I knew it was 95%, and this is the middle right here, I'm looking at my graph, right down the middle, I'm putting in purple, and one of the boundaries is this. Can I just subtract these two? Subtract the higher one, take the higher one value right here, your maximum for that 95%, and subtract the point estimate and figure out what that distance is. That's basically your error. And you could have, okay? If you subtracted these two, you would have gotten the same thing, okay? All right, so this is about half the work, okay, for today's lesson, and it all dealt with means, okay, or averages, okay? Whereas the next one deals more with proportions, okay? And again, just like averages, okay, I have a hard time finding what a true average is. Further, I cannot find always a population proportion, okay? So this average is not going to be used in this part of the work, okay? We're actually going to deal with proportions. And let me read the statement to you. It says, when an individual pays off, okay, his or her credit card statement in its entirety and before the end of a billing cycle, then the credit card owner is not charged a late fee nor any interest fees. Okay, so of the 30 people who were surveyed on the previous slide, okay, because remember there were 30 data values, 13 were able to pay off their complete bill within the next billing cycle. Okay, find the point estimate. Okay, now again, realistically, I can't find this P. Okay, I can't find the proportion of all people across the United States who paid their credit card bill off during the month of January in its entirety. Okay, it's too hard to ask anyone and everyone. Okay, however, I can take a sample of 30 here and get an estimate. Okay, and hope that whatever my estimate is, that it's going to be close to this population proportion. Okay, now, how do you find your estimate? Well, I'm going to identify it with something different, and it's not going to be an X bar like before, because I'm not talking about means, I am talking about proportions. And since I'm using my sample of 30, I'm going to use a hat for this. And of the 30 that were identified for the sample, it said that 13 were ones who paid their credit card bill off within that month. Okay, so they paid it off in its entirety during the month of January. Okay, some people in the past said, "Hey, complete January bill." Shouldn't we put that in there? And probably I should. But again, I referenced the 30 people from the previous slide, which is for kind of a tie into this problem. If you want to change this to a decimal, you certainly can. Okay, this gives you 0.43333 for a long time, okay, forever, okay? And they ask you to do the same thing as before. It says draw a normal distribution and label the point estimates and 3 standard deviations in each direction, okay? So luckily for us, we don't have to put a bunch of numbers into our list, okay? However, what I am going to do is draw my normal curve. And right down the middle, I'm going to use my sample P, which is 0.4333. Okay, and really that 3 goes forever. And I need a standard deviation, and they didn't quite give it to us like they did in the past. Okay. However, if you remember from a previous chapter in sampling distributions, the standard deviation of all your p hats will be, in this case, I'm going to have only p hats to use, p hat times 1 minus p hat all over n. Okay, so what you'll have to do is use your calculator to come up with the value for 13 over 30 times 1 minus 13 over 30 divided by 30. Okay, and you can put that in your calculator, see what you get. Okay, I'll just let you know when I did this math. Okay, I got 0.0904. Okay, and so what I did, just for myself, okay, I didn't want to worry about this 0.04. I just added sets of 0.09 to each side. Okay, so as I make 3 standard deviations in each direction, 4 now proportions rather than means. Okay, I'm going to add 0.09 to this, so that's 0.523. The next one is 0.613. And the last one is 0.703. And if you go the other way, it is 0.343. And then 0.253. And the last one is 0.163. Okay, and remember 1, 2, and 3 standard deviations, just like before. Let's see if I can draw just a little quick one right here. Okay, here's 1 standard deviation. That is 68% of all your data. If you go 2 standard deviations, that is 95%. And the last one, of course, is 99%. Okay, and so we can match up these numbers along the horizontal axis to help represent questions that they may ask later on about 68 or 95 or 99% confidence intervals. Okay. Now, a little hint, a little trick. I'm going to just tell you, they're not going to ask you for a 68% confidence interval, but I wanted to show you what it was just so you can see the pattern of how things kind of work. Okay, so nothing really changed. It says describe a 95% confidence interval. This is the same question. The only thing that happened is that my items disappeared. Okay, if I go back to it, it'll still be there. But let's just describe it like we typically do. I'm not going to draw a picture again. If it's like before, we would say this. We would say, we are, that's a bad R, but it's still there, 95% confident. Okay, the interval from, now remember that 95% confidence is 2 standard deviations in each direction. So if I go to the previous slide, and maybe you already wrote this down, we'll look at it real quick. 2 standard deviations is to here, 0.253, and the other one is to 0.613. Okay, so those are both 95%. From 0.253 to 0.263, okay, captures let me erase this real quick. Captures the true, and then watch this. I'm going to change something up here. Just a second. True population. Now we've already written 3 sets of confidence interval statements, and the next word we always used was the word mean. However, we're not talking about means now, we're talking about proportions. Okay, so you're 95% confident the interval from 0.253 to I wrote this backwards, 0.613. Let me just correct myself real quick, sorry. 0.613 captures the true population proportion okay, for, and then we got to put this in context. Okay, so for, now what are we talking about here? People who pay off their January credit card bill. People who pay off okay, their January credit card bill. Okay, and again, notice the sentence looks almost exactly the same as before. The only difference is that we have a new word here. We're using the word proportion, okay, as we should, because we're not talking about means anymore. And but the rest is pretty much the same. It's all in context, okay. And again, we're talking about people who pay off their credit card bills on time for the month of January. Okay, like before, it says what is the critical value and what is the error. So when I think about 95%, this is p hat plus or minus. Notice I did not put an X bar there. We're not talking about averages. This is proportions. And normally this, we'll talk more about what symbol I use there, but this is the number of standard deviations away. Sorry, the number of standard deviations that you will either add or subtract from your proportion, okay? And in this case, we have a 2 there. Okay, so what is my critical value? My critical value, I'm just going to put underneath here, is 2, because that is right. 95% is 2 standard deviations away. 99% is 3 standard deviations away. Okay, and what is our error? Remember, error is the part behind the plus minus symbol. Okay, it's the things that you're adding or subtracting to each side of your point estimates. Okay, so 2 times your standard deviation, and your standard deviation in this case we said was 0.09. And so our error is 0.18. Okay. All right. I've got one more piece. Okay, we're not going to do 99%. Okay, this is fine. By now, I think you understand how to write the sentence. The only thing I want to emphasize again is making sure you use the right term for the the point estimate that we're using. We're using either proportions or we're using, in this previous case, means, and you want to make sure you identify that in your sentence. Okay. All right, the last thing is a confidence level. Okay, and confidence levels use a little bit different statements, and it looks almost exactly the same as the one before. Okay, it looks one that looks just like before, 95% confidence interval. Notice I'm highlighting that underneath. And this one just says level. Notice that it's all in caps, okay? And those are unique, okay? You can't interchange these answers when you see these types of questions, okay? And here's what you're gonna do, and I'll give you a little explanation after this and see if I can fit it in somewhere in this, this PowerPoint slide. But the statement's gonna go like this, and I'll write it all in red, and I'll write the part that changes in a different color from question to question, but they will all begin like this, okay? Here's what we're gonna say. If we were to repeat this method many times. When I say method, it's kind of like this procedure for finding a confidence interval. Okay. Now, because I'm using the word 95% confidence, I'm going to include that again. 95% of the resulting confidence intervals will contain the true population, long sentence, sorry, proportion, for, and it's the same thing as before, people who pay off their January credit card bill. For people who pay off their January credit card bill. Okay, and so let me see if I can underline a piece real quick here. This part here will always adjust based off your context, okay? Whether you're talking about means or proportions, and then what's going on afterwards. What are you talking about with respect to your story? Okay. Now, some of you are like, man, that's kind of hard to distinguish between level and interval, okay? And so on your note sheet, you'll notice that there is a little table that gives you information on both, okay? And so you can kind of practice using the structure of your sentences accordingly, okay? And up on the screen is what we have. That follows what we've been practicing. Confidence interval, which you see right here, okay? I'm kind of highlighting this in a blue. Uses the same item that we've been using for all of our confidence interval descriptions. And then when you look at confidence level, okay, we do the same thing just below it, okay? We use what you see in here, okay, to describe what you see at the bottom down here, okay? So it's written almost word for word the same thing. The only thing that I changed was this part in the back, okay? The true parameter value, and again, always write it in context, even though that's not put there. Okay. All right, so those are also notes they're on your note sheets. On your note sheets, they're at the very, very bottom of your last sides. Okay, so if you want something to kind of reference, even though you've practiced this a lot already, it's there. Okay. All right, so that's on your note sheet at the very bottom. Here's the last thing. Okay, and since we're in the holiday season, I'll kind of reference one of my more favorite movies. It's Buddy the Elf, and from the movie Elf, we say that he's a brilliant toy maker and statistician. He keeps records at the North Pole for all the number of toys that are made per hour on average throughout a year. It says for 50 random hours, Buddy reported a 99% confidence interval of 20,217 toys to 28,429 toys. Okay. Now, what does that mean? I'm going to put this at the very top. Okay. And let me use a different color so you can see this a little bit more easily. I'll do green. It means, hey, you know what? I've already found your answer. Okay. I've already done the calculation. And in the end, there's your minimum part of your boundary, and here is your maximum. Okay. And here's what they ask for. They say, hey, what's the point estimate? If I'm giving you the answer, what is the question? Okay. If this is the lower part, okay, and this is the higher part of your confidence interval, okay, then what was in the middle, okay, and then further, what did you have to add to this side and subtract to the other side so that in the end you got these boundaries? Okay, now sometimes students will look at that and say, oh my gosh, I don't know how to find that middle. Okay, and it usually means they're not thinking hard enough, because if I were to change it around a little bit and say, hey, let me put this down here because I don't want to. Yeah, I know. Oh, I'm okay. Okay, if I put, say, 10 here and 20 here, and I ask for the middle, yeah, you could find it. Okay, you know the halfway spot between 10 and 20 is 15. And if I needed a super elaborate calculation algorithm for it, all you're really doing is doing the average, adding 10 plus 20 and dividing by 2, which gives you 15. And if I were to do the same thing here, if I were to add 20,217 plus 28,429 and divide it by 2, I come up with 24,323. Okay, so my point estimates will be that number. I'm going to write it right underneath. And I have to decide if I'm going to use a p hat or if I'm going to use an x bar like I did in the first part. Remember, x bar dealt with averages, p hats deals with proportions. Okay, and because in this problem, I'll circle this in green, I'm talking about averages. Okay, then that's what I'm going to write. I'm going to say x bar is equal to that. Okay, 24,323 toys per hour, okay, on average. And then remember, the error, okay, is the distance from your point estimate to either the maximum value or your minimum value, okay? And so, like, if I'm looking at 15 here and I need to go to 20 and I'm asking, hey, what's this distance? Most people in their head could say, yeah, I can see that distance is 5, just like this distance to the outside was also 5. And if I were to ask students, what operation did you use to get this value of 5? Most would say, hey, I took these two here and I subtracted them. Or I took those two there and subtracted them. And I'd have to do the same thing here to find the error. Okay, I would take your boundary of 28,429 and I would subtract the point estimate, the item in the middle, which you just found, 24,323. And when you do that, you get 4106. Okay, and that is our error. Okay, here's what I'm going to do for the next part. Okay, and I've already kind of given you the sentences up here. I've written these confidence intervals many times, okay, for you already. 4 times at least, okay, so far for this lesson. I'm going to pause this. I'm going to give you a moment, or ask you to pause it, okay? Give you a moment and see if you can write your sentence accurately, okay? That's really what you're being judged on quite a bit with respect to not only 8.1, but much of 8.2 and 8.3, okay? So do me a favor, pause this just for a second, and see if you can make a confidence interval, okay? Interpret the confidence interval for 99%, okay, as it shows, so it shows in the instructions. Okay, and do an interval and then do the new one, the level. And if you get stuck, you can look at this kind of table on the top here to help guide you through that. And in the end, we'll see if yours looks something similar to mine. Okay? Okay, so you do that and I'll do one as well. Pause. Okay, welcome back. Okay, here are my answers. Check them out. I'll let you read my answers first if you can handle my handwriting. And compare them to yours. I use pretty much the same lingo as the phrasings in the table above. But for my confidence interval. I said we are 99% confident the interval from 20,217 to 28,429 toys, okay, captures the true mean number of toys that are made per hour at the North Pole, okay. The confidence level, which is the next one, has kind of a different unique representation, and it says if we repeated many samples using the same method multiple times, okay, maybe it's a little redundant in that, but that doesn't hurt, okay, 99% of the confidence intervals, let me write that in, I put just intervals, confidence intervals would contain the true population mean number of toys made per hour, okay. I'm going to talk just a little bit more about that in a second, okay? I'm going to talk about this last question, and then on my next slide, which is more blank, I'm going to talk just a little bit more about confidence levels, just to make sure that you get the idea of it. I know you could kind of memorize the sentence and go through that, but I'm going to give you just a little diagram to kind of help explain what that is, okay? All right, now here's the last sentence, and it really kind of lets us know that you understand what's going on, okay? Think about what our second last sentence says. It says, describe a 99% confidence interval, okay? It says we are 99% confident, okay, the interval from 20,217 to 28,429 captures the true mean number of toys that are made. Again, I'm going to write this off to the side. The mean number of toys made is unknown, okay? There's too many hours in a day, okay, to figure out how many toys are made per hour on average, okay? Too many hours in a day, too many days in a year, and Santa has been around for centuries, okay, to figure out how many toys are made per hour on average, okay? But we have an estimate for this, okay? We had a point estimate of around 24,323, and then we came up with this interval, okay? And so we believe that the true mean is somewhere in between those. In fact, we said that we are 99% sure that the true mean is somewhere in between those, even though we really don't know what that is. Okay. All right. So here's my last question. It says Santa's elves claim to make, on average, 30,000 toys per hour. Is there convincing evidence to suggest that this is true? Okay. Now, if we think about 30,000s, okay, is it likely that they make this many per hour? Okay. Now, not 30,000 every hour, but on average, as it's suggested, okay, which means sometimes they'll be a little bit below, sometimes a little bit above, but on average, 30,000 per hour. Okay, now, in order to answer this question, you have to look at the information before it and try to make sense of it, okay? If I tell you from the second question here, for part 3, okay, I'm putting a little star by it, that we are 99% sure, that's almost 100%. We're almost completely certain that the average has to be between 20,217 and 28,429. Does 30,000 seem to fit the mix between those two? And the answer is no. Okay, no. 30,000, okay, is not 30,000. I'll just say toys per hour is not within the confidence interval. And so if it's not within the confidence interval, then I don't believe it to be true. Sorry. Okay, meaning I don't think the elves are giving a truthful statement. I'm going to say that kind of quietly because they probably made some of the gifts for me that I received this past holiday because I'm usually a pretty good guy. But yeah, 30,000 is kind of inflating it, okay? Because again, we are 99% confident, okay, that the true average is really no higher than 28,429. Okay, that's as high as we think it's going to be on average. Okay, their estimate is a little too strong. Okay, now while this is your assignment from your textbook, keep in mind that this is probably multiple choice. Okay, and these are not full blown out confidence interval problems. The first bunch are going to ask you for like point estimates and errors and things like that. Okay, and so don't think that all of these represents kind of like what you see on one slide of a PowerPoint. Okay. All right, here's the last thing I want to talk about. Confidence levels. Okay, and again, I know you can write this sentence, but what does this mean? Okay, and let's say I talk about a 90% confidence level. Okay, now here's the deal, and the one that I think I did this one was the ones who pay their credit card bill on time, the proportion, okay? And I have no idea what the true population proportion was, okay? But I came up with some interval, okay, that said, you know what, I'm 95% sure that these are the boundaries that the true proportion could be within. Okay, now that's just mine. Okay, that's the data that I found. It could be that the data that you would ask for a small sample of people would give you a different confidence interval. Okay, that may look like this. Okay, and maybe your buddy does a different sample of 30 people or 35 people or 40 people that gives you a different confidence interval. Okay, and maybe another buddy gives you, another set, and so on. Okay. And here's the deal. The P does exist. We may not know what it is, but I'm just going to draw it in right here. There's P. It does have some value, and all I know that it's probably in between my interval and my buddy's interval and your interval, etc. But it's only going to be in 90% of confidence intervals of samples that were created the same way, okay, and using the same method. Okay, so I've got 1, 2, 3, 4, 5. The sixth one will probably contain it, maybe the seventh one, but there's going to be one where you actually collect honest data and it's not going to contain the population proportion. Okay, it's possible that you get a sample that actually doesn't contain it. Okay, and so that's what a 90% confidence level is. I got 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so this right here, if I consider my population, this value, I don't know what it is, but if it extended all the way down, okay, you can see that 9 out of my 10 confidence intervals that we would all independently find, okay, actually contain this true P, okay, the true population P. And there's only one that didn't, and it's this one right here, okay, and this is just someone's random sample of, I'm going to again say 30 people that gave some proportion that extended in this direction, the higher direction, the more positive direction above this true population proportion. Okay, and so when I say 90%, that's what it means. 9 out of 10 of your samples, okay, and you can do many, many more samples, but 9 out of 10 or 90% will actually contain the true population mean for all the little possible confidence intervals that could exist for individual samples. Okay. So there you go. I hope that makes sense. You'll see some diagrams of something that I have here in your book, and I hope this is a good representation to help you gain some understanding of, again, a confidence level. All right, there's your assignment. If you have questions, let me know. And here's some good things. We have 8.2 and 8.3. I'm going to write this here real quick. 8.2 and 8.3 is exactly what we just did in 8.1. The only difference here is 8.2, I'm going to deal with proportions. 8.3, I'm going to deal with averages. Okay, I'm going to use the same thing as before, p hat plus or minus. I'm going to call this z because z is the number of standard deviations away that you'll be from your point estimate. And these numbers won't always be numbers nice like 2 and 3. Okay, they may be something of a decimal, okay, somewhere in between. And similarly here, this will be x bar plus or minus z times the standard deviation. I'm going to have some rules I'm going to include with this, but have no fear, you've already learned them. We're just going to incorporate them into these lessons. Okay, so I don't think these will be too intimidating as long as you have a good understanding of 8.1. Alrighty? All right, I hope you have a good night or a good day, wherever you're at in your time of day when you watch this.